Greetings, ladies and gentlemen. My name is Ryan Shazani and welcome back to another physics video. In today's video, I'll be explaining the phenomenon of why when you take a bottle of water or a glass of water and you spin it like this, or you spin it around in a circle, you'll create a tornado shape of water. But more specifically, the shape of the water is a hyperbola. So why does this happen? Why is it specifically a hyperbola? Now let's take a look at this diagram. So the hyperbola, the minimum height of the hyperbola will be h naught, the infinitesimal of the height will be dh, the radius of the hyperbola with respect to the center will be r, and the infinitesimal of the radius will be dr. The way we're going to approach this question is by taking a look at an infinitesimal cube of water. So this is the m. The m is an infinitesimal cube of water, and I'm going to draw this cube of water, and I'm going to say that the dimensions of it will be dA. So the sides, the surface area of the sides will be dA, and the width of it will be dr. So I can say that dm is actually equals to the density times the volume, which is just dr times dA. Okay? Next, we're going to consider the forces acting on this cube of water. So, if you take a look at the forces, there'll be forces in all kinds of direction. But the most important thing is to remember that this question is about a circular motion. Therefore, the forces you have to consider will be the centripetal force. The centripetal force is the force radially inwards of the circular motion. So, i.e., we just have to consider the horizontal forces. So let's call this F1, let's call this F2. And because the centripetal force is radially inwards, therefore I can say that F2 is greater than F1. Therefore, F2 minus F1 is equal to the centripetal force, which is just dm r omega squared. Okay? Now, what is F2 and what is F1 exactly? Remember, dA, or the surface area, the infinitesimal surface area, is an infinitesimal, so it's just a point. Therefore, I can say that the force, or F2 and F1, is just the same as, for the take pressure equals to force over area. Force is therefore equals to pressure times area. I can say that the pressure at F2, or at this point, is equals to, or the force at this point, F2, is equals to the pressure at this point's time times the area, right? And what is the pressure at this point? The pressure on the left hand side is just rho times H2 times G, and then the force, to find the force, you take the pressure times the area, A, which is dA, minus rho H1G dA equals to dm r omega squared. Okay? Now, what is the next cause of direction? I can substitute the m from here. So, the m is just rho dr dA r omega squared. And I can simplify this equation. Cancel the rho, cancel the dA. I'll get H2 minus H1 equals to dr r omega squared over G. Now, what is H2 minus H1? Remember, this is an infinitesimal. This is dr, right? So the distance between H2 and H1 is infinitely small. Therefore, this is just dH. So dH is equals to r omega squared over G dr. And I can just find the function of h to be h equals to the integral of r omega squared over G with respect to dr. So this is just integral from h naught to h, and this is just from 0 to r. Okay, so I'll get h minus h naught equals to omega squared over G, and this is just r squared over 2, and I'll get h should be equals to omega squared over g r squared plus h naught. So h is equals to omega squared over 2g times r squared plus h naught. And voila, this is a parabola. And this is how you show that the shape of the water is a parabolic shape. Thank you for watching. If you enjoyed this video, if this video helped you, then make sure to subscribe, like the video, and share the video. Other than that, I'll see you in the next video. Goodbye.